Hello friends. Today we are going to have introduction on ER diagrams and ER model. The relationship data model perceives the real world as consisting of basic objects called entities and relationship among these objects. The ER model was developed to facilitate database design by allowing specifications of an organization's schema, which represents the overall logical structure of a database. The ER model is a high-level conceptual data model developed by Peter Chen in 1976. It was developed to facilitate database design, and the purpose of developing a high-level data model was to support end users' perception of data and to conceal the more technical aspects associated with database design. The ANSI Standards Planning and Requirements Committee enhanced the database standards in 1975 and defined three different data models based on their degree of abstraction. These namely are conceptual, external, and internal, which we also call as physical. The data models that is independent of both the database software and the hardware is the conceptual model. A visual representation of this conceptual model, we call it as conceptual schema. It is um, the most popular conceptual model is the entity relationship model, and this conceptual schema associated with it is ER diagrams. This conceptual data model, as we can see here, is a set of concepts which describes the structure of database and the associated retrieval and update transactions on the database. The basic components of this model is like we call it as ER diagram, which we use to visually represent the data objects. So we can say that ERD is a visual representation of ER models. ER models is of great utility for database designers as it is like the constructs that we make can be used in the ER model and it can easily be transformed into relational tables. It is also very simple and easy to use, like less training is required in using the ER models or ERDs. The model can be used by the database designers to communicate the design to the end users. And we can also use this ER model as a design plan by the database for the database developers to implement a data model in a specific data management software. There are various components of ER model. The three main components are entity, attributes, and relationships. The ER model forms the basis of the ER diagrams. It represents the conceptual view of the database. Let's have a look on all the three main components one by one. The first component of ER model is entity and the entity sets. What is an entity? Entity can be referred as a thing or object in the real world which is distinguishable from all the other objects. An entity can be described as a class of persons, places, objects, events, and concepts about which we need to collect and store data. But we also have to remember that each entity is distinguishable from the other entities. Categories can be categories that we can include in the entities are displayed on the uh, presentation. Like we have persons, places, persons like it could be employees, customers, students. Places can be offices, rooms, any specific building. Objects can be referred to as a mobile phone, a book, a machine, a vehicle, it could be anything. Events can be a specific sale or any registration, any order that we can make, the reservations that we do, it can all be reported in the events. And the concepts can be the course, stocks, qualifications. It all includes, like, it all will be called as the entity. The instance of an entity is a single occurrence of that entity. For example, like entity employee, it may have multiple instances or occurrences, like there could be many names like X, Y, Z. So we can save the data in the name of entities. Entity set is like it is a set of entities of the same type that share the same property, like the entities which share common properties or attributes, we can call it or group it as the entity set. For example, the set of all employees working in one organization can be called as the entity set for employee. Next is the attribute. An entity is represented by a set of attributes. Attributes are used to describe the entity. Attributes are descriptive properties possessed by each member of an entity set. There are different types of attributes which we can use in making the ERD diagrams. We can have various types as key attributes, composite attributes, multi-valued attributes, and derived attributes. Key attributes basically are the attributes which holds or which can uniquely identify each entity in the entity set. The other is the composite attribute. Composite attribute is the attribute which is composed of many attributes, like an attribute which is composed of multiple components, we can say, each with an independent existence is called a composite attribute. Like some attributes can be divided to yield smaller components, like if we for example, if we take name attribute, then it can be composed of various components like first name, middle name, last name, and so on. The next is multi-valued attribute. Multi-valued attributes are the attributes which contains more than one value for a given entity. Like a multi-value attribute is one that holds multiple values for single entity. It have multiple values for a particular entity. Like a student can have multiple values for hobby attributes. Like a student's hobby can be reading, music, playing, movies, and so on. So a multi-valued attribute may have sets of numbers with upper and lower limits. Then next is the derived attribute. The derived attribute is the attributes which can be derived from the other attributes of an entity types. Moving on to the next slide, we have the next component is the relationships. The relationships can be defined as an association among several entities. In terms of relationship, we define its type, its set, and also the instances. Relationship type is what entities and their types participate in a specific relationship. The relationship set tells us about a set of relationship of a specific type. Relationship instance is the relationship between two entity instances. There is also a degree of a relationship which shows the number of entities which are associated with the relationship. Then we have the mapping cardinalities, which also defines the relationship between the various elements. Mapping cardinalities, or we call it as the cardinality ratio, it expresses the number of entities to which another entity can be associated via relationship set. Mapping cardinalities are most useful in describing binary relationship sets, although they don't contribute to the description of relationship sets that involve more than two entity sets. For a binary relationship between the entity sets, we can call or take an example as A and B. The mapping cardinalities can be of different types, like 1 is to 1, 1 is to many is to 1, and many is to many. For having the mapping cardinalities 1 to 1, for example, an entity in A is associated with at most one entity in B, and an entity in B is associated with at most one entity in A. So there should be one-to-one relationship, and this one-to-one relationship is known as one-to-one mapping cardinality. Then we have one-to-many. In one-to-many, going with the same example of A and B, an entity in A is associated with any number, 0 or more, of entities in B, and entity in B, however, can be associated with at most one entity in A. Then we moving towards many to one relationship or mapping cardinalities. With the same example of A and B, an entity in A is associated with at most one entity in B, and an entity in B, however, can be associated with any number of entities in A. Then we have the last mapping cardinality as many to many to establish the many-to-many relationships. An entity in A is associated with any number of entities in B, and an entity in B associated with any number of entities in A. Then we will call it as a one-to-one mapping cardinalities. So many-to-many relationship describes an entity that may have many relationship amongst each other. For example, one customer may may order many items, and one item may be bought by many customers. So this can be the example of many to many relationship or many to many mapping cardinality. These are the various symbols which we use in ER diagrams. These symbols and notations help us to make an ER diagram which we further use to communicate with the end users. Here we can say that here we can see that entities can be shown in a rectangular box or by the help of rectangular box. For showing the attributes, we can use eclipse. For describing the relationship between the entities, we have a diamond box. For representing the weak entities, we have double rectangular box. For identifying the relationship between two entities, we have double diamond box. For the derived attribute, we have a dotted ellipse. The multi-value attributes can be represented by double ellipse, and the composite attributes can be represented as shown in the picture. The cardinality and modality notations can be defined in the given way. And this is all about your ER diagrams and ER model. Thank you so much.